Hello and welcome to this short tutorial on using STM32F1 with ROS. So I'm going to start from scratch. So let me just go ahead and say file new, and I'm actually going to say it's a C++, sorry, in new project. All right, and I'm just waiting for my GUI to start up. Yep, and so that it is. And what I'm going to do here is I'm going to do STM32F103 RT, RCT6, and select that and say next. And now I'm going to actually do STM32F1 and just say ROS test is my project. I'm going to actually select this one as a C++. Still I want to use that. Go next, and still use the HAL library there. Copy only necessary files. Say finish. And what I've also done is I've just connected my programmer in USB there. So as you can see, we're going to use the UART, and our UART is going to be, let me pick up my files down here. Where is my, that's the core board. Just going to go for the schematics and just show that's my USB to serial converter, and over here you can see it's actually connected to the type C. This is my converter which is using transmit and receive 1. When I come down here, that's my transmit and receive is down here. So that's connected to PA9. So I'm just going to keep this open. Let's go here. And since I'm actually going to be using this, go here, enable my clock. I'm going to go my system, debugger is serial wire. So those two are going to be set. And another one is I'm going to actually go down to this UART1 and make it asynchronous, and go to parameters and also set this as 57600 with both receive, but I'm also enabling my DMA for my receive. Just leave it like that. Add for my transmitter, just get that done, and user settings, come to NVA, just make sure that this is also selected, the global is selected. Alright, and what else I have to do? If I have to configure it for my other sensors, I need to do the connectivity. For now it's okay. And then I also wanted to do timer 2. I just want to just enable this, just give it an internal clock, just leave it like that. That's pretty much it. And go to clock settings, set this guy to maximum frequency, which is 72. Yep, so everything else is set up. What else I need to do? Let me just go to this guy and just double check if I have that. That's good. And that's pretty much it. So what I'm going to do is go back to and save it. And it's actually going to do this guy down here. You have the main file, but the source would now be C file. I think since you've declared it as C++ project. Let me just go to properties. I'll have to check this. If not, I'll have to rename this file at the end, and then because it's actually saying here converted to C, so this is actually running as a C++. Alright, so these are here, and now what I'm going to do is can I go a terminal from here? Yeah, no, it's not possible. So the next thing I'm going to do is bring up this one down here, and I can show you this is the STM32 ROS serial package, and what we are going to do is we're going to clone this. So I'm going to just say, so you can see I'm going to actually do this. Let me just look at this over here, and then say git clone and do that. And basically for me it's going to actually create a folder here, and so what I've also done is I've actually created a package called that, and I've actually placed this is my earlier version of the thing, so you can actually do this too, but for now you can just simply clone that, and it has all the files. So down here I'm going to do catkin make, and then you can see it's all done, and then I'm going to do a source and say that's I'm using a Z shell, so I do that, and then I have to go into the folder. My folder is in STM workspace, and then that is the one I created is STMcube-F1 ROS test. I go in there, and I'm in this folder, have the core, so I have to go inside the core folder, and what I have to do now is, as this one says, you will have to do a ROS run should contain the include and the source directory. So which means this is where it actually includes the source directory. I'll have to do this, and it's just asking me where you want to copy it from, and I'm just going to say copy it from 1, and then it just copies the whole thing. And now once it's done, you can see down here, if I do a refresh, go to my include, there's all your files, and then it also does put the STM hardware files, and you can change this over here. I'm just going to do if defined and defined. I'm going to copy this one more time and just say if you have a 1, so define that, and I'm going to actually change your device F1, and then mark this as F1, mark this as F1. So it's actually going to take define F1. If not defined, it's actually going to pick up from there, right? And so here you have an external thing which is by default going to 2, so we are just going to change that to 1 because that's the thing that we are using. Save it and go to the main file, and there's your 1, and now we're going to actually include over here the folders, and so I'm just trying to for now we're just going to do the hello world. So give me 1 second. I'm going to pick up my file where I have this, which is the chatter. I think that's pretty much what I need to change, because still the message is too small. Yeah, and then just include these two files in here, which is ROS and standard message string, and come down here and also include these guys, which is user begin 0, user begin 0 and end 0. We're gonna add that. So what we've done is we've just done a node string publishing all those different things. Okay, all right, yeah, this should be okay. And so in my main on the for while forever, what we're just going to do is we're just going to publish our, or you have to do the setup and then just call the loop in there. Okay, so small thing is user begin code. So this is the user begin init. So you have to have your setup, and in down here you just say loop, and let's right click on it, go to properties, path and symbols. It's already in that file. I'm not sure. Yeah, it should be okay. If not, I'll come back to the and go to the linker to do the compilation. Yeah, and then just make sure that's also set. For printf, impulse build is the hex file. Apply and close. Let's do the build. It's probably going to complain because okay, and it says unknown namespace ROS. Where is okay? Yeah. So yeah, let me go back to this guy. So that's that. I think it's just user begin code is 0. I will, let me just convert that file into a C++. Probably it's just has some issues with the because I think it's still considering that as a C file. And it says, oh, there's somewhere there's UART 2. Yeah, so change that to, that's actually in the STM. It was still defined there. Okay, and then now it has a warning, but again, so that's as a UART defined there, and it's UART1, reset buffer, and I have to probably change that. Let me just pull up this file again, my reference. I've changed in a few places, so so what I've done here is, that's all you want is fine. Didn't we? Okay. And so it's just complaining that over here, I don't know, let's transmit length, and I think gotta go and okay, that's the thing. It says end buffer. Okay, so I actually had to delete that too. So I deleted that because of the buffer. Okay, let's now compile this again. Build project. Yeah, and so that's fine. All right, so now, so these modifications, we are good. And what we're going to do there is, let me close these files. And I'm actually going to, I've set the baud rate. I've actually made this guys to simply say hello robots down here. Okay, and then I'm gonna also change this to every 1 second. Okay, let me change that. So let's build this again. Oh, maybe this is not the file. Where's my loop? Oh, so it's actually set up as there. Loop is here, and here. Let's see. Okay, I'll even make it better, quicker. Let's see how it goes. All right, and then I'm just gonna say. Yep, so that's the build. It's done, and what I'm going to do is I'm going to actually burn as connected. Say okay. So it's actually going to start waiting for the debugger. Download is done. Everything is verified. So I'm going to come to my here, run ROSCore, and over here do a ROS run, ROS serial would be Python serial node. Okay, give me 1 second. Okay, let's do ROS serial Python. There you go. Yeah, I need to check. Before that, let me check if where's my so I can see my ST link, and that's the one. So I'm gonna actually check. Yeah, I have one, and oh, there's nothing. Okay, so it looks like I have it back to 0. So, and then it should basically start requesting the topic, and it should get the data. All right, so it's just not getting the data. So I have to verify, you know, this 2 USB ports, ls dev yeah, this is only one. Let me go back and see what I have done with this, guys. Okay, that's the UART is the only one that I'm trying to do. I did this over here. I will need to check one more time what I did in here with the chatter. Did I do the interrupt for the timer? I have to check for my timer. So that's the internal clock I did. And this is my system core. That's the thing. System is serial wire. And we see, okay, I have the UART1 global. That's all I've done. Alright, so this looks like, what else did I do with the connectivity? Is that, so I have that, Nothing else has changed. So let me go back to this one. Because I think in this particular case, I'll also have to see what else did I modify in my STM32. That's the main. Do I have that in there? I don't have a main.h, do I? Okay, I need to also create another file because this is another file. So this is duration. I don't know if I modified anything with the duration. ros.h is standard time. Okay, I don't think I've modified any of this. So let me copy. Okay, so that was copied there. So now you have main.h, which basically defines that's a C++ file. Now what I need to do is I need to actually clone it, go to properties, and I'll go to file types, and then this was created. So I can see that this is HPP is also there. So let me build this again. And get back to this file over here. That just has main.c. And let me check up. All right, so I have a setup here, so that does the setup. So I'm actually looking at main.h, rosh, that's that. We have those things, and then followed by this. I might be actually, so that's been advertised. And where's my publish? Yep, publish been once. And that's the loop. You see if I put the loop in there. Yep, in the while. Setup is there. Okay, I'm gonna actually move this to the after this. Let's build this again. And let's build this. Okay, loading is done. Yeah, there you go. So I think the setup should be done. So it says here the chatter is not getting published. And then I can do topic list, and I get chatter, and you can do topic echo with chatter, and there you go. So it just prints out hello robots that are there, and that's pretty much what we wanted, right? So let me control C. So let me just modify this. I have too many things open. Let me close all of these guys. All right, so I'm gonna go back to and enable this guy to be output. I think that's where my LED is connected. Let me save this. Hopefully it's going to actually, so yeah, so it looks like it actually did create a main file there, and it's going to be empty, and I have to redo it even though I do a C++ file. So all I'm going to do here is in this init, I'm going to copy this my GPIO. After I have this, I'm going to actually copy this whole thing down here. I have to probably redo it, it doesn't pick up. Alright, so copy the whole thing. So now my GPIO 4 is actually set as an output. Is there anything I need to do? Let me just double check. Okay. Save this. Just quickly going to compile this, even though I've not modified it. I just want to make sure it doesn't have any errors. Okay. So that's done. And then what I need to do is I want to come back here, and I'm going to create a subscriber. Okay, I'm just going to copy it from different source. So let me do a subscribe of toggle LED, message that, and I'm going to actually do this, which is function. Let me write this down up here after this. Okay, let's copy this, but instead of digital write, I'll have to write how. So, okay, I'm just going to go my LED example and pick up the code to toggle the LED. So every time that gets called, it's just going to do, let's say, toggle LED. So this is going to be I should write, forget, pin set. That's not going to be set, I have to toggle it. Okay, let me it's going to be I'm just picking up, what is it called? HAL GPIO. It's not right, it's going to be toggle pin, and it's going to be, this guy is going to be GPIO P. Yes, and this is going to be GPIO pin underscore 4, I guess. Yes, or I can just put GPIO, or just put PB underscore 4. That will also work. So what we're doing here is now we're also doing it as a subscribe, and I think pretty much that's to spend once, but actually on the subscribe I have to also now have, instead of advertise, I have to say I have to do a subscribe, and I'm subscribing for, this one is called sub. Okay, something. Okay, so, and then when I run this, it's probably going to pick it up. All right, so that's pretty much what I need to do. Already, I think in this code, I need to initialize my GPIO, which is there. Okay, let's do this. Build it. Okay, get this compiled, that's fine. And let's build this guy, and let's go back here and let's run this guy again. So now you're going to see it's going to also have 2 topics. Now it doesn't seem to pick up the subscription. So let me just quickly press the reset. I might have so this is okay. Let me exclude this guy. Build selected file. How do I exclude? Yeah, so say exclude from the build, because I don't need the C file. It should be, it's probably doing the empty file. So just the main file. Yep. So let's do this. Probably I did one. There you go. At least ROSCoreBoard cannot convert integer. Oh, I forgot to include the header file now. So this is include. Say, I think it'll still be standard messages, and then say okay, because that message was empty. Yeah, this is empty dot hedge. Okay, let's see. All right, so let's enable this. GPIO for pin was not okay. You knew there was something. I'm just going to put PB4. I think that should work too. Nope, it doesn't like PB4. What does it want? GPIO. I think that's GPIO. Let me just put so it should let me see. PIO pin 4. It should okay, let me go and see what is up there. What is it called? That's what it is. Alright, pin GPIO pin 4. I don't know what I toggle pin GPIO pin _4. Okay, build. Yep, alright. I don't know. Maybe I had something different there before. I have to just go back and check, but alright, so that's done. So let's compile this. Build, again done. We're waiting for the download to finish. Done. And let's go back here. Let's do this one. It's requesting for topics. There you go. So now I have toggle. So let me show the. Yeah, I think it should still be okay. And nope, that's not the photo. Oops, my bad. I don't have the camera connected. Let me connect the camera. One of those days. Yep. So that's my board. You can see, and then there is this LED is off. And what I'm going to do is I can do ROS topic list, and then you can see I got toggle LED, and now I have to now individually, so I can publish now ROS topic. I can do info on toggle LED, and it says it's of type serial empty, so I'm going to do a ROS topic publish. Let me pull up this and keep it there so you can see this LED here is off. I'm not sure how to zoom that, but anyhow, LED is off. Public, publish, and I have to say toggle LED. It's of type standard, message empty, and then it's just it's an empty message, and I actually do once, and you can see that LED just turned on, and it'll be on if I do it again, and then the LED goes off. So you can actually control a simple example. There you go, it's on, and it still holds on to the value till I do something to that, right? So that's so if you are actually trying to make bigger, I think this one it's talking about the message lengths. If you want to actually increase, then what we can also do is modify. Let me see if I can. Okay, just wanted to make sure that I'm still recording. We can also modify this. So this default is value over here is 512, and what you can do is you can actually increase that to 1024. So, and then you should be able to get large amounts of data sent through the serial buffer. So for now it's like 512 bits, I guess, or bytes is what it's actually going to go out. But you remember, also you have the header information, all those things going on. So if you have issues with the buffer, you can actually increase these values to 1024 and try. All right, so that's basically, a quick demo, and thanks for watching.